Welcome back. Today we are back to Python and we are going to dive into new topics. We start with one of the most essential aspects of programming, file handling. Files are everywhere, from storing data to reading configurations. Knowing how to work with them efficiently and safely is a must-have skill for any programmer. By the end of this video, you'll know how to open, read, write, and close files using Python, all while following best practices. Let's get started. File handling is all about interacting with files from your Python code. This includes reading data from files, writing data into them, and closing them properly when you're done. Whether you're working with text files, logs, or data files, Python makes it easy and efficient. The first step in working with a file is to open it. Python's open function is the key to this. Let's start with an example. Here we open a file called example.txt. You can create a text file with this name and write something to it, just to test. And the file is open in read mode. This is what the R after the file name means. We read its contents and then close it. As you can see, open is a function that accepts several arguments. The most common ones are file name, which is the first argument. It can be the file name or path. This tells Python which file you want to work with. Mode, the second argument, specifies the mode in which the file should be opened. Some common modes include R, read, which is the default, opens the file for reading. W, write, creates a new file or overwrites an existing one. A, append, opens the files for writing, adding new content to the end. And B, binary, used when working with binary files like images or audio. For example, you can combine these modes such as RB for reading a binary file. Now that you know this, take a look at the code again. Now, with a little bit more knowledge on the modes. Always remember to close the file after you're done to free up resources. Now, let's talk about creating files in Python. To create a new file, you can use the X mode with the open function. This mode will create a new file. Here's an example of how to create a file. X mode is used to create a new file and open it for writing. If the file already exists, Python will throw an error, ensuring that you don't accidentally overwrite any important files. This is useful when you want to create a file that doesn't exist yet and safely write to it. It ensures that the file you're creating is new, avoiding the risk of overwriting an existing file. You can also use W mode to create files, but unlike X, it will overwrite the file if it already exists. Use X for safety and W when overwriting is acceptable. Once a file is open, Python provides several ways to read its content. Let's look at the four most common methods. .read reads the entire file as a single string. This is useful when you want to load the entire file into memory at once. For small to medium-sized files, this method is straightforward and allows you to easily manipulate the entire content as a single string. .readLine reads one line at a time. This method allows you to read a single line of the file on each call. It's useful if you want to control the reading of the file manually, reading lines one by one or stopping after a certain line. You can process one line at a time and have more control over the flow of reading, such as looping manually or breaking early. Read lines. Read all lines into a list where each line is an item. This is handy when you want to read all the lines into a list for later processing. It reads the entire file into memory, but it gives you the file content split into individual lines. It's useful if you need to keep track of all lines separately and process or index them later, like sorting, filtering, or doing something with individual lines as a list data structure. For loop over a file reads the file line by line. This method is ideal when you want to process each line of the file individually without having to worry about manually managing the reading process. It's memory efficient and great for large files because it reads one line at a time. It automatically handles reading the file line by line and doesn't require you to manage the position in the file manually. Using the strip method ensures that any extra white space or new line characters are removed from each line, giving you a cleaner output. You're probably thinking that using readLine or a for loop seems similar. Here's a better explanation. When reading files line by line, both the for loop and readLine method are commonly used. The for loop is simpler and more concise, automatically iterating over each line without needing to manage the file position. It's great for straightforward tasks like printing lines one by one. On the other hand, readLine gives you more control, allowing you to explicitly read each line and manage the file position, which is useful if you need to skip lines or read specific sections conditionally. If you need simplicity and clean code, go with the for loop. For more control over the reading process, readLine is your best choice. These methods are flexible, so you can choose the one that fits your needs best. Reading is only half the story. What if you need to write data to a file? Python makes that simple too. To write to a file, open it in write or append mode. Write mode overwrites the file if it exists or creates a new one. Append mode adds data to the end of the file without erasing its content. Let's see this in action. And to append, when writing to files, always double-check the mode to avoid accidentally overwriting data. Closing files is crucial to prevent resource leaks. Now you might be wondering, isn't it a hassle to always remember to close the files I open? Well, I've walked you through the hard way, so you truly understand it. But now, let me make your life easier. While the close method works, there's a better way, using Python wait statement. This ensures files are closed automatically even if an error occurs. With this approach, you don't need to call close. Python handles it for you. Always use with open for safe and efficient file handling. Another important aspect you need to start paying attention to is errors. Errors happen in programming, a lot. So we need to have a safe measure in place to keep track of these errors and handle them properly. This is a very big topic, and we will dive deeper into it later. But for now, let's talk about some common errors you might face when working with files. FileNotFoundError. This error occurs when you try to open a file that doesn't exist. If the file missingfile.txt does not exist in the current directory, Python will raise a FileNotFoundError. PermissionError. This happens when you try to access or modify a file without the proper permissions. If read-only-file.txt is a read-only file, or you lack right permissions, this will raise a permission error. Is a directory error. This error occurs when you try to open a directory as if it were a file. If my directory is a directory rather than a file, Python will raise an is a directory error. I/O error. This is a more general error related to input-output operations and can happen under various circumstances, such as a failure to read or write due to file system issues. While I/O error is less common in regular file operations, it can occur due to issues such as hardware problems or corrupted files. These are some errors you might encounter on your programming journey. In the next episode, we'll show you how to handle these errors along with others you may come across. To test out our skills, let's build a program with what we learned today and what we learned in past videos. We're going to create a grocery list program where the user can add and remove items and then save the list to a file with a custom name when they're done. Here's how we can do it. In this program, the user starts by interacting with a menu that gives them three options: add an item, remove an item, or exit and save the list. When the user selects the option to add an item, they're prompted to type the name of the grocery item they want to add. The program then takes that input and appends it to grocery list, which stores all the items the user has added. This makes it easy for the user to keep adding more items dynamically as they go along. If the user chooses to remove an item, the program first checks if the list is empty. If there are items in the list, the user is asked for the name of the item they want to remove. If the item is found, it's removed from the list. If it doesn't exist, the program informs the user that the item wasn't in the list in the first place. This ensures that the user only removes items that are already on their list. Finally, when the user selects the option to exit, they're prompted to provide a name for the file where the list will be saved. If there are items in the list, the program saves its item as a new line in a txt file with the name provided by the user. If the list is empty, no file is saved, preventing the creation of an empty file. This program is designed to be interactive, allowing the user to add and remove items from their grocery list dynamically. Each time they make a change to the list, they can see the updated version. When the user decides to exit, they provide a file name and the program saves the list to a file for future use. It's a simple yet powerful example of how Python can handle user input and manage files. Not only does it cover file writing, but it also teaches valuable lessons about creating interactive programs that respond to the user actions. It's a great way to start exploring how to work with files and user input in a practical way. Today, we covered the essentials of file handling in Python: opening, reading, writing, and safely closing files. These skills are foundational and will come in handy for a wide range of projects, from data processing to log management. Now it's your turn to practice. Try creating a script that reads from one file and writes to another, or experiment with the different modes like write and append. The more you practice, the better you'll get. If you found this video helpful, don't forget to like, subscribe, and comment below. Next time, we'll dive even deeper into Python's powerful capabilities. Happy coding, and I'll see you in the next dimension.